Number 5.
Number 5.
Okay. So please write down the reporter's name, the opponent's name, and the reviewer's name. So we have to copy down, the juror will have to copy down the name on their scoring sheet.
确定啊，确定。
Reviewer, please write down the name, please.
干嘛？陈第二个。陈右起。没有，我在跟他讲话。开始。按下去。对。陈悉尼第二个。对。不要！春高。
这个准备时间之内跟3队稍微解释一下，就是因为今天评审提问的话，我想我会尽量给评审的稍微多一点的时间问问题哦，这样才能把一些争点把它问出来啊。那所以跟大家先抱个歉，如果因为评审提问耽搁到你们一点时间的话，真的很抱歉了。但是就是说，我想毕竟老师们是就这样尊重一下了哈。 好，那还剩下1分钟。So the reporter, please go ahead. You have 12 minutes.
Hi, we are from Wooding Senior High School. We are going to report pinhole rock. And problem 7, the pinhole ball is placed in a container of water. When the container is dropped, the pinhole ball will get launched to a very high. What maximum height can you reach with up to 2 liters of water? And if you pull down the top and the ball will go up. And we define a problem because the problem didn't mention how high the container was initially placed. So when we complete the 2 liter one, we select it at about 0.5 to 0.6 meter high. If too high, we cannot control it and measure the maximum of height well. Also, it didn't limit the material of ground, so we look for the best ground. It's our parameter. The volume of water, the height we throw pinhole, the kind of ground, the volume of pinhole in the water, the radius or area of the bottle's opening. If if the bottle is too small, the ball might stick on the bottle and it will make the result different. We used to make to stay in middle of water, but didn't make it cannot get out. It's our data. First, different ground materials. Just like this, since that the orange one, plastic and yellow one rock are better than all the others. Also, some of them present a high linear correlation because the maximum of height must be 0 when the initial height is 0, so it may be a direct ratio correlation. Okay. Second, different radius of bottles. The blue one is the best. This is that the smaller radius is the higher the ball goes. Third, different volume in water. According to the result, the blue or orange one just flow on water or kept in water situation. Are big and different different water volume. Just like this. When the water volume is 0.001093 cubic meter, it will get to this height. And their units are all meters. And if we just change initial height, just like this, and we calculate the mass and initial height ratio, and this result doesn't present a direct ratio correlation. Many reasons can make it happen, such as the bottle is spinning, the bottle is not smooth, etc. And we are going to solve the original problem because the bottle we had couldn't contain exact 2 liters of water, so we contain about 1.8 or 1.9 liters, and the result just like this. And the highest one is 2.17 meter. Okay, our conclusion. First, plastic and rock ground are better than all the others. In other words, if the ground is smoother, the result will be better. From the result of radius experiment, the smaller the radius or the area of bottle was, the higher ping pong got. Third, according to all the results, the correlation coefficient of most of the data is not high, but they are all positive. That means the higher ping pong was initially, the higher it dropped. After fourth, the bottle need to be dropped vertically, and that the process of dropping is needed to control. The higher the ball is, the more uncertainty exists. Okay, thank you for listening.
Okay. So the question from the opponent to the reporter, please go ahead.
Yes, I want to ask your setup. You say you drop it vertically, but how do you do that?
The initial high, if the initial high is lower, the uncertainty is less. Sorry, I don't know how you mean.
Oh, I say you have to drop it vertically, but how do you drop it?
We drop it perpendicular and we put it less higher. The air resistance will cause less uncertainty.
Okay, so like even like you release it like or something and you release it.
What did you mean? Huh? Just we want to
and your unit. What is this unit?
all these are all meters.
All the meters.
Yeah.
Okay. And do you consider the error bar?
Huh?
Error bar.
Yeah.
Error bar. Error bar.
What?
The error bar, your mistake in your instrument.
I don't know what.
Okay, it's about time, so let's go to the next phase. So the opponent will have 3 minutes for your preparation. Then you will have 40 minutes for your, say, discussion with the reporter.
I don't know. That's
Okay. The opponent, please go ahead. The reporter, please stand by for the question from the opponent.
Okay, I want to summarize the reporter's report. And first, pros and cons. His pros is data enough. He do a lot of variable. Cons, the world is too small. We could not see it. And the theory is not enough. I don't know what is theory. So I will ask him next. And time control is bad because he only said 4 minutes. And his theory, like the bottle is too small, it will stick on the bottle. The variable, different methods of bottle volume in water. And his experience, he do the different mineral on the ground and the water's bitter. And his conclusion, the smaller the ground is, and the higher it will be. And I will discuss with the reporter. Thanks.
Okay. Just go ahead.
First, the experiment one. So can you? Okay. You say this, so it may be a direct pressure. This, and why you mean this one? Why you this one? Oh, it is a function. I thought. But why can you draw this line, this function?
There are regression line of the same color point.
Okay, and you say that your material will similar and your height will higher. But how do you define it? The similar. But how can you see it? Oh, sorry, I want to see the first page.
We just use light.
But how do you define the amount of the growth amount? Your smooth amount. Smooth amount.
We did not do that.
But you say the smoother your growth is, but the higher the height. But how do you define the more smoother? And you say that the growth is like this. But how do you define the amount of growth? If it's more, so how do you find it more? Okay. Sorry. Next one. So and when dropping the water, how do you know the height? How do you know the height? How do you measure the height? Because the height has a lot of water in your piece. Your maximum height, and I'm sure your data is maximum.
This is from
Oh, sorry, this is what?
this and
How do you define the maximum height?
just
The water maximum height. Water maximum height. Water. You drop your water and ping pong and water, because you say your height is ping pong height or water height. Is water or
all these are all
the ball or is a ball? Okay. And what is the perfect growth? This one, what is the perfect
perfect.
growth? I mean, which is the highest? Because this and this was no more is like this, but how do you define?
So we think we just we after
Okay, I see. And why and experiment two? No, this one. What radius of the bottle affect it? Affect the ball side? Is this both heights? Both. The
Yeah,
height?
all of these are all 4 height.
Okay, okay. And why it will affect it? Is this what is the second series? Can you explain the signal of it?
We observe that the radius of bottle will event that we did not think about this
Okay,
initially.
you didn't think about it. Okay. And I want to know experiment 3. What? No. It's you say you couldn't measure the 2 liter, but you measure 1.8 and 1.9 liter. But how is its index amount? What is this?
I don't know what you mean.
Why is this amount? You say it is 1.8 to 1.9, but
Okay, we fill the bottle to about this height and we measure it is 1.8 to 1.9.
but do you know the index amount? Because you have to consider the error about it. So I don't know what's this mean.
Our container cannot contain.
Oh, okay, I see. So you don't contain this one. Okay. And next one, can you explain the radius one more time? I don't understand. So you see that is all the disc. This one is the disc.
Yeah.
It's the rod. Rod disc.
Yes.
Rod. Oh. And do you think the difference of the container and the no. Why the ball sink during falling down? Sink. Do you avoid that the ball will sink? Sink. When falling down.
Falling
You do the experiment. The first one. You do the experiment. Yeah, this one, the experiment picture. You say up. It's drop and it will sink. Do you observe it?
No.
No, but
I don't know how to.
oh, okay, next one. So you don't consider about this. So do you consider the water will spread out? Because I drop water down, and water will spread out. Do you consider the water spread out?
Usually the ball go before the water is spread.
Sorry, I don't know why.
Ball fly first and water spread second.
Spread. Do you consider the water spread out will affect the height of the ball?
No, it didn't spread before. Before the ball leave Arm.
How do you measure this? How do you think? How do you find that it won't?
We took video and we observe them.
But how can you observe it?
We have time frame per second.
Observe functionality.
We have time frame per second, so we can see that.
Oh, do you use some tools to observe it?
Yes,
Can you say what tools you use?
just phone camera.
Oh, okay, I see. So, and thanks.
Yes.
So now the opponent will have 1 minute for your summation.
Okay, the first question I ask it is the material about the rock, and I don't think I have a clear answer because he doesn't tell me how can he define the smaller amount. And the second one I ask the radius affect the ball, and he say the radius bigger and the ball will more higher, but he don't show me the series. And I ask the 1.8 to 1.9 liter, but he doesn't tell me the exact amount.
So now the reviewer, you are up. You have 3 minutes to question the reporter and the opponent.
Okay, yeah. Now I'm gonna review number 5 ping pong rocket, and I have questions for the reporter. In our conclusion, okay, switch to that page. Okay, in our conclusion, we said, according to the results, the higher the ping pong ball is initially, the higher it gets, right?
Yes.
So, you think that there are no boundary limits for this experiment? Is that so?
The bottle may just go up, and we cannot measure the limit because our device cannot get to that height.
Okay. And so, do you think that air resistance is what you should consider when you're calculating the maximum height?
No. No.
And why do you think so?
Because most when we drop the bottle, most of them just not vertically drop on the floor.
Okay. So, questions for the opponent. And do you think the formation of the cup affects the experiment? It affects the maximum height?
I think it will affect because the ball will up and the water will spread out and its deformation will affect it.
Okay, I have one more question. You asked about the smoothness, and how do you think it affects this experiment?
Oh, sorry, can you say that again?
Oh, you were discussing about the smoothness of the ground, and how do you think it affects this experiment?
I don't think it will affect the. Sorry, I think it will affect, but I don't hear the amounts of smokes about the
ball in the middle? And do you think it causes energy consumption?
Okay, sorry, time's up. So I think it's the time for the preview for your preparation. You have 2 minutes. After that, you have 4 minutes for your review. Okay, the reviewer, please take the floor.
Okay, I'm the reviewer, Michael from ND Fresh, and today I'll be reviewing problem number 5, ping pong rocket. And this is a problem statement. And there are some main focuses of the reporter, like different ground materials, different radius of bottles, different water volume, initial heights that affect the maximum height. Okay, and this is the overview of the reporter. The advantage is that they have massive variables considered and a clear definition of the problem. And our suggestions will be that they need to be more accurate while doing the experiment setup and methods, and clear explanation of focuses and theory. Also, their analysis of data isn't quite clear. And what is the database? And they didn't actually answer the problem in the problem statement, which is the maximum height. Okay, next page. And the overview of the opponent. The advantage is that there are further questions about the answer problems, and my suggestions will be that there will be clear expressions of their ideas. Okay, in the discussion, the opponent says how to drop a container vertically, and the reporter says the air resistance will cause it uncertain. And my opinion for this is that it will result in inaccurate experiment data. Okay. And next one is what are the units of the diagram and error bar? And the reporter responds with meters and nothing. Our opinion is the causes for error bars, notations for units in the diagrams. And the other is how you draw the lines in experiment one diagram. And the reporter says there are lines from the same material. And my opinion for this is that putting the theory lines in their graph will be more appropriate. Okay, and the opponent asks, what's the perfect radius of curve? How does the radius of curve affect the rebound height? And which is what the reporter didn't consider. And my opinion on this is that different radius of heights may cause different amount of energy consumptions, which might affect the experiment. Okay. And what I asked the reporter is how to measure the exact volume of water in the container, and he responded they're using containers of about 1.8 to 1.9 liters of water. And my opinion on this is that the volume errors might affect the data analysis. And the next question is, does ball sink during falling phase, which the reporter didn't consider? My opinion on this is that it's a factor. It's a factor that affects the experiment. And that's all of my review. Thank you.
Okay, so now the reporter may make your final remark. Reporter, please.
Okay. First, we should do further experiment to know to define the smooth amount and just make it. The shape of bottle and radius of the container should be considered. Okay.
Okay, I think time is up. So now we have to let our juror to ask questions to all the reporter, the opponent, and the reviewer. Please stand by, and now the juror may ask you a question if you like. Please go ahead.
I have a question for the reviewer. I didn't hear too much your comment to the opponent. Yeah, can you like summarize your what did they do for the opponent part? What did they do like the best and the worst? Can you say it again?
Oh, they have further discussed in many factors like the ground materials and the formation of the cup. And what they didn't do very well is they spend a lot of time on the same question, and they only and they aren't very into their whole experiment.
Yeah. You want to say something?
Oh.
You want to say something?
Okay.
No? Okay, thank you.
Please.
So I have a question for you three. So for the reporter, that from your experimental data, you show that as the drop height increases, that the ping pong will be launched to higher a certain height. So will there be a critical height that the ping pong can reach? And what do you think if you increases the drop height to even a higher value, what's the height of the pinhole will be launched?
We didn't observe that there will be maximum height and
So, okay, so do you think that will there be a maximum height limitation for the maximum
yes.
height? Okay, thank you. So for opponents, what do you think?
I think the energy, the energy,
The energy?
like delta U equal to mgh, so the higher, I drop the bottle higher and the ball will get a higher height.
Okay, so how about the review?
I think initial heights and the maximum diffraction of energy that transfers from the water to the ball and air resistance are the main factors that make the maximum height.
So any more questions? Okay, go ahead.
I have a question for the reporter. Can you go back to the different material yeah, and what is your conclusion from this control experiment?
Can I answer?
I don't know. Can other people answer?
Okay.
The girl thing, the smoother surface.
For one second, can other people answer?
I think so. I think it's allowed. Please go ahead.
Okay. I think the smoother surface is the higher the ball gets.
Yeah, but I mean, because the opponent asked the reporter like how did you measure the like even the roughness, but I didn't see the answer. So since you don't have this roughness information, how do you get this conclusion?
It seems that if the reflection is more uniform, the smoother the surfaces. So the report saying that plastics has a great uniform reflection. So saying plastics and plastic has actually high. So yes.
Okay, if there's no more questions, I think we have had so the jury now will calculate the score for each team, and when we will show the score by the order of reporter, foreman, and reviewer. So now we will show the grade for the reporter. We have to take some time. Don't worry. Okay. 4, 4, 3, 3, 4. Okay. So now for the opponent. Okay. 5, 5, 7, 4, 5. Okay, so now for the reviewer. 6, 6, 6, 5, 6. Okay, if there's no further question or the juror would like to make some comment. If